What's up, everybody? It's Mr. Cop. I told you I would post an answer key for the Volcano Review slideshow presentation, so here we go. Get your docs open and double check your answers. If you have any questions whatsoever, feel free to email those to me, and if I have time, I'll do like an Ask Me Anything. Maybe I'll answer these questions in a YouTube video or something to that effect. Anyway, let's get started. So we're going to analyze a volcano. Right here, this is Mount Fuji, and if you notice here with Mount Fuji has pretty steep sides. Those steep sides come from the fact that the lava that comes out doesn't flow great distances. It's kind of sticky. Right? So it's going to say, well, type of volcano. The type of volcano here, it's tall, but it has pretty steep sides. That's going to make it a composite or stratovolcano. Composite stratovolcanoes have alternating layers of that sticky, high viscosity lava, as well as layers of ash that falls, or tephra that falls on top of it. So lava, tephra, both, it's going to have both. Its height, I said before, it's pretty tall. All right, this actually builds directly off the ocean floor. If you remember, Japan is an island arc at a convergent boundary, a subduction zone. So the magma that feeds this is actually way down below this island. It's all the way in the mantle. So height, we're going to go with tall. Slope, pretty steep size. If this was a shield volcano, it would be very flat. You almost wouldn't even notice that it was a volcano at all. So it's going to have steep sides here for Mount Fuji. Type of lava, well, those steep sides are formed because of the sticky, high viscosity rhyolitic lava. Rhyolitic lava produces light-colored igneous rocks. Rhyolite is a light-colored igneous rocks with that silica-rich mineral, so this is going to produce felsic igneous rocks. And because it's silica-rich, glass, lower temperature, it's generally going to have a higher viscosity, creating those steep sides. And then the high viscosity felsic rhyolitic lava has more silica or glass minerals in it. So there you go. There's 1 through 8. Double check your answers, and we'll keep moving. If you have any questions, again, shoot me an email. All right, so where is Mount Fuji? Well, Mount Fuji is located here in Japan. This is the Pacific Ocean. Got the United States, here's California and Alaska and all that good stuff. Hawaii is over here in the middle. It says, if the snow melted, what volcanic danger might form? Well, you may recall, hopefully from the notes, that lava is pretty hot, and when it rapidly melts the ice or snow that's on top of it, that snow is going to mix with the tephra that's on the volcano, and it's going to produce a concrete mudslide called a lahar. What are some of the other potential dangers? Well, any composite or stratovolcano is going to have pyroclastic flows. You can have ash, lava flows, any of those things, blocks and bombs shooting out of it. So those are the dangers. Its last eruption was in 1717. You should recall that an active volcano has erupted in the last 100 years. A dormant volcano has erupted in the last 1,000, and an extinct hasn't erupted in the last 1,000 years. So 1717 is about 300 years ago. That's going to make it dormant. That's between 100 and 1,000 years. What type of eruption? Well, I said before, composite stratovolcanoes are going to have explosive eruptions because of that sticky, high viscosity rhyolitic lava. So this is going to have explosive eruptions. Number 13, what volcanic zone is Mount Fuji located in? This happens to be the Ring of Fire here that rings the Pacific Ocean. And why do the volcanoes exist? Because this is all subduction, convergent subduction zones all around. So there you go. Double check your answers. Obviously, you could pause this and fill them in if you needed to. So let's keep going. This is a pretty cool picture. We have all of the big island of Hawaii in comparison to Mount Rainier. So we have this giant shield volcano of the big island of Hawaii with multiple vents, Mauna Loa and Kilauea. And then you have that compared to a pretty standard composite or stratovolcano. So you can see Mount Rainier, which is a big mountain, 14,000 foot plus mountain in near Seattle, Washington. Compare that to what a shield volcano looks like growing off the ocean floor. Is quite a difference. So it says, why is Hawaii's surface area so much larger? Well, that's because of the low viscosity basaltic lava that flows out great distances and builds the island that way. So it's because of the lava, the low viscosity lava. All right. Where are shield volcanoes typically located? Well, they're located typically at hotspots. So we have large volumes of hot, low viscosity basaltic lava, which is going to produce very large volcanoes like this. Why does Mount Rainier have steeper slides? Well, that's because Mount Rainier has rhyolitic lava, which has higher viscosity. Also has those alternating layers of tephra, which is the ash, the dust, the lapilli, the cinder, the blocks, and the bombs. All right, so here we go. We got two different types of lava. Which lava has higher viscosity? Well, which one is not flowing as far? Remember, high viscosity means sticky. This lava over here does not seem to be flowing like this lava river that we have over here. So high viscosity lava does not flow as much. That's going to be letter A. Which lava probably has a higher temperature? Well, iron requires a higher temperature to melt than glass does. And when it does melt, though, it is able to flow greater distances. So B, this is going to have a higher temperature, this basaltic iron-rich lava. Which lava probably has more silica? Well, our high viscosity, low temperature rhyolitic lava, letter A here, is going to have more silica. Which lava will probably form lighter colored rocks? More silica, more glass, lighter colored rocks, letter A. Which lava is more typically associated with hotspots? Had that in our last question about Hawaii. Hotspots have larger volumes of lava, and obviously it has hotter lava, and it's basaltic, which flows a greater distance with low viscosity. So which lava is more typical? This should be letter B. I gotta fix that. All right. Oh, there it is, B. So let's keep going. Number 23, name two gases that are coming out of a volcano. Well, volcanoes have carbon dioxide and water vapor. All right, a little bit of nitrogen. Usually it's whatever's in the early atmosphere is what's coming out of a volcano. Hydrogen sulfide, hydrogen chloride, things of that nature are coming out of the volcano. No oxygen. Right? Oxygen in our atmosphere comes from photosynthesis. What are the solids called? Well, the solids are called tephra. And we have tephra based on size, dust being the smallest, then ash, then cinder, then lapilli, then bombs and blocks, I believe. And all you have to know really is that the names represent the size. It's all made of the same stuff. List at least 3 sizes. I did that. If the cloud raced down the side of the volcano, what would it be called? It would be called a pyroclastic flow. Pyroclastic flows when this superheated ash and lava blocks, bombs come flying down the mountain about the same speed as a jet airliner, a few hundred miles an hour. You can't outrun it, and when it gets you, it's game over for you. What type of eruption is this? Well, this is an explosive eruption with the tephra coming out. Quiet eruptions is just lava. What type of volcano? Explosive eruptions occur on those steep sides. That's going to tell you it's a composite or stratovolcano. So here we go. Here's our answers. That's carbon dioxide, hydrogen sulfide, hydrogen chloride, sulfur dioxide, tephra, ash, cinders, blocks, bombs. You also have lapilli and dust in there. Pyroclastic flow races down the mountain. Explosive eruption, composite stratovolcano. All right, 29. Why do so many people live near volcanoes? Well, there's a bunch of reasons. The number one reason is because we have really good farmland there. The soil is very fertile around these volcanoes. Volcanoes are also nature's way of recycling minerals. So this is where we're going to have maybe some deposits of certain types of ore that we can't find anywhere else. All right. And there are other reasons, of course, tourism. Some of these volcanoes are found in beautiful tropical areas. There's some extinct volcanoes. There might be some mountain climbing. I mean, people do climb Mount Rainier. It hasn't erupted in a long time. Of course, there are some dangers associated with that. What type of volcano is this? Well, you got steep sides. Those steep sides are going to be composite or stratovolcanoes. These are the ones that you most typically think of when you think of a volcano. What might be the greatest danger? Well, that's going to be a pyroclastic flow. It's the greatest danger that to these people. I don't see any snow on here, so it's not going to be a lahar. Ash and dust, you could get buried with ash, but typically it's the pyroclastic flow, which doesn't give you any time to escape. So there you go, there's your answers. Number 32, what type of volcano is this? This is a little cinder cone. How does it form? Cinder cones form when a tiny bit of lava, usually just a vent of tephra, just pops out of the ground and builds a small little hill with a tiny little crater in it. Right? So a single eruption usually. Where do they form? They usually form in fields of volcanic areas, also on the sides of other larger volcanoes, side vents. Why are they so small? Because they don't erupt much lava, and they only erupt once or twice. What are they normally made of? They're normally made of tephra, typically cinder. Okay. And then our anatomy of a volcano. We have our magma chamber underneath, which feeds our conduit or our pipe, which goes up to our crater. It's also known as a vent. Wherever the lava comes out is known as a vent. Notice the alternating layers of ash, dust, right? The tephra and the lava. So this is going to be a composite volcano. That's what these things are showing here, coming out. And then you have sills and dikes. Sills go laterally in between the layers. The dikes go vertically. So here you go, number 12. Number 12 is the magma chamber. Number 11 is the pipe conduit, right, with the vent at the top. Lava flow is number 2. You see lava flowing down. Number 5 is the crater. Number 6, tephra's coming out. That looks larger than these, we'll see, right? Side vent. Number 3, it's the side vent, so it's 9. And then number 8, we have a pyroclastic flow because it's flowing down the mountain. And that should do it, everybody. If you got any questions, please email. Don't worry about bothering me. I will get back to you as soon as I can. Have a great day. Good luck on the quiz tomorrow. Check in. Bye-bye.